Today's lesson will be on the area of a triangle. This is from section 4 in chapter 7, and this should be log page 4 in your logbook. The area of a triangle. From many years ago, when you first started studying geometry back in middle school, you learned the area of a triangle was equal to 1/2 the base times the height, where b is the base and h is the height or the altitude drawn to that base. We're still going to use this formula, but we use this formula when we know the base and the height of the triangle. So what if we're not given the base and the height? Suppose we know two sides of the triangle, A and B, along with the included angle, gamma. Well, we can derive a formula for the area of a triangle by noting the following. If I have any triangle, I can find its height by dropping down a perpendicular from the vertex to the opposite side. And from my right triangle trig, I should notice that the sine of gamma is equal to h, which is the opposite side, divided by a, which is the hypotenuse. So the sine of gamma is equal to h divided by a. Well, if I want to solve this for h and find out what h is in terms of the sine of gamma, I can simply multiply both sides by a and find out that h is equal to a times the sine of gamma. Now I can take that h and substitute in place of the h, a times the sine of gamma, into my formula for the area of a triangle. So a equals 1/2 the base times the height now becomes a equals 1/2 the base times a times the sine of gamma. A and b are the two sides of my triangle, and the sine of gamma being the included angle. So 1/2 a times b times the sine of gamma. This is the formula that we're going to use if we know two sides of the triangle and the included angle. Now recognize that you know that these are two sides and the included angle because A, B, and gamma is not directly across from either of these two sides. Because if it was the angle across from A, it'd be alpha. If it's the angle across from B, it'd be beta. Since it's gamma, we know it's the two sides and the included angle. Now, just like with the law of cosines, there are three different formulas for this area of a triangle. The area of a triangle equals 1/2 the product of two of its sides times the sine of its included angle. So, if we have sides A and B, we know we're going to multiply by the sine of gamma. If we have sides A and C, we know we're going to be multiplying by the sine of beta because that's the included angle. And if we have A equals 1/2 B times C, we're going to be multiplying by the sine of alpha. If you read the words on this slide and try to learn the pattern instead of trying to memorize all of these letters, then you won't have to worry about it. You'll know the formula. The area of a triangle is 1/2 the product of two sides times the sine of the included angle. So let's look at an example. We have a triangle that has sides A and C. A is 5 and C is 7. We also know that beta, which is the included angle, is 70 degrees. So we're going to use this middle formula right here because we know we have the two sides and the included angle that go with that. So the area of the triangle is equal to 1/2 times 5 times 7 times the sine of 70 degrees. And now all I'm going to do is put that into the calculator, 1/2 times 5 times 7 times the sine of 70, and I'm going to get approximately 16.44 units squared. Area is always in square units, so don't forget to put units squared. Now, what would happen if we knew 3 sides of the triangle instead of 2 sides and the included angle? Well, we have a formula for that as well, and this is called Heron's formula. The area of a triangle with sides A, B, and C is equal to the square root of S times S minus A being one side of the triangle, times S minus B being the second side of the triangle, times S minus C being the third side of the triangle. This is Heron's formula. Well, what is S? S is 1/2 of the perimeter of the triangle. And the perimeter of the triangle, obviously, is A plus B plus C. So S is 1/2 the perimeter of the triangle. So let's look at an example using Heron's formula. Find the area of a triangle whose sides are 5, 8, and 11. Well, they don't tell us which side is which, so we're just going to let A be 5, we're going to let B equal 8, and we're going to let C equal 11. The first thing that I'm going to do is find out what S is, because that's the only piece that I don't have. So I need to know what S is so I can put into Heron's formula. So S is 1/2 of the perimeter, 5 plus 8 plus 11. Well, 5 plus 8 plus 11 is 24, and 1/2 of 24 is 12. So we have the perimeter, half of the perimeter is 12. That's our S. Now we're going to substitute in the things that we know into Heron's formula. The square root of S, which is 12, times S minus A, which is 5, times S minus B, which is 8, times S minus C, which is 11. So A is equal to the square root of 12 times 12 minus 5 is 7, times 12 minus 8 is 4, times 12 minus 1, which is 11. So that gives me the area is the square root of 336, which we can simplify to 4 times the square root of 21 units squared. Now, the way that we simplified that is we looked for a perfect square factor of 336, which would have been 16, because 16 times 21 is 336. And then we said the square root of 16 is 4 times the square root of 21. Okay, this is an exact answer. And if we wanted an approximate answer, we could have just put that into the calculator. I hope this has been helpful, and now we'll get ready to answer some questions that you might have on this information in class tomorrow. Y'all have a great night.